Hey, good morning, everybody. Well, it's morning here where I am. Hey, with this time, this time. I don't know what I'm saying. So, Mr. Mayas is here with you, and we are going to do anti-differentiation. So, this is lesson 5.4 in Essentials of Calculus. I'll have two videos, I think, on this. The first, I'll show you what we're doing with anti-differentiation, and the second, we'll look at the position, velocity, acceleration stuff that we did before. Only this time, we're going to go backwards. So, let me get situated in this chair. All right, let's get going here, guys. So first thing I'd like you to do is some warm-up examples here. So why don't you just differentiate these three, pause me now, differentiate these three, and then come back and we'll take a look at some of these here. All right, so we're just going to take the derivative here. And you should have gotten the derivative for each of these. And you should notice that the derivative for all of these are the same, but we've got a different constant each time. So when you anti-differentiate, you have to add that constant in because we don't know where that might be. It could be anything added or subtracted to that first polynomial part. Because when we do the derivative of that, it just drops out and is 0. So to do the antiderivative of that, we got to put it in there. So the antiderivative of 3x squared, notice here, if the derivative is 3x squared, then the antiderivative is going to be x cubed plus c. Plus c, that's going to be very important, all right? So when we talk about anti-differentiation, we can also write it using this little integral sign, looks like a little thing on a violin there. That symbol is called an integral symbol. And the integral symbol, the integral of 3x squared dx, we got to put that dx there, the differential, is x cubed plus c. All right, so we've got an integral, which is the same thing as an antiderivative. We've got an integral power rule. And the power rule says basically we're going to add 1. So last time, remember, when the power rule, we do derivatives, we subtract 1. This one, we're going to add 1, anti-differentiate. So we're going to add 1 and then divide by n plus 1. Remember, with the power rule, for derivatives, we would subtract 1 and then multiply that over, right? So this time we're doing anti-differentiation, okay? The constant rule for anti-differentiation or integration is that the integral of a constant is just the constant times x. All right, so I'll give you an example in just a second. The scalar multiple rule means we can bring out the constant k. We can just bring it out of the integral and then anti-differentiate anything that's inside of there. And then the sum rule means we can just anti-differentiate anything with sums in it. So like a polynomial, we can just do the antiderivative of each thing inside of it. This saves us time. We don't have to write the integral out each time, but we do have to know that we can do that if we needed to. All right, and we'll see some examples later on where we're going to need to actually do our work where we have to split the integral up, but for right now, we can just do the anti-differentiation of the whole thing inside. All right, so let's take a look at the first few examples here. We're going to use the power rule here, which was we're going to add 1 this time, right? So we're going to add 1, which is 4, and then divide by that, and then don't forget plus c. That's all there is to it. Pretty simple, right? Okay, constant rule. This is going to be 2x. This is a dx, so it's going to be an x plus c. That's it. All right, this is one where we have the sum rule, so we're going to do the first one first. T to the 5th over 5 plus 2t plus c. Don't forget the c. All right, that's all there is to anti-differentiation. Well, you know, they get a little trickier, but that's kind of the opening. So let's take a look at some more examples that are a little bit more tricky. Well, more tricky, it's not a word. A little bit trickier here. So we've got a sum here. So we're going to go 2y. What are we going to do with the power? We're going to add 1. Okay. Plus 4y. We're going to add 1. So it's squared. Divide by 2. Plus y, right? Because I said so. Okay. Plus c. All right, so for those of you that like things simplified, looks like this. Okay? All right, let's try this next one here. Now, anytime we see any problems that we have with powers in the denominator, for now what we're going to do is we're going to bring those up to the numerator, right? So we're going to have x to the negative 2 minus x to the negative 1/2 dx, the integral of that, and now we can use our power rule. So we're going to add 1. Negative 2 plus 1 is now negative 1. So we're going to have 3x to the negative 1 over negative 1 minus x to the now negative 1/2 plus 1. Right, negative 1/2 plus 1 is positive 1/2 divided by 1/2 plus c. Okay, now if you want to simplify that, you're going to have negative 3 over x minus 1/2 root x plus c. Let's take a look at the next one. Now, here's another rule of thumb that you should have for all of these. Whenever you see a monomial, okay, a monomial in the denominator, you should always split that monomial into the parts of the numerator. So we're going to have square root of x over x squared plus 1 over x squared dx. All right, we're going to switch these to powers here. So we're going to have integral of x to the 1/2 over x squared plus 1 over x squared. And then 1/2 minus 2, right? We're gonna simplify this guy right here. We're going to simplify this here, and that's going to be x to the negative 3/2, because I'm going to do 1/2 minus 2, plus x to the negative 2 dx. Whoa, what happened to my screen? Just wanted to not zoom in there. Oh, come on. Okay, so now we're going to add 1. So negative 3/2 plus 1 is negative 1/2 divided by negative 1/2 plus x to the negative 1 divided by negative 1 plus c. All right, we want to simplify that. It's 2x to the negative 1/2 minus x to the negative 1 plus c. That's good enough. We don't need to get crazy there, okay? All right, so sometimes notice that we always put a c, right? Sometimes you're going to need to solve for c. This is a note. Just make sure you know that note. We never do it on differentiation, but when we integrate, we do. So sometimes we have what's called an initial condition, and the initial condition makes it so that we can solve for c. We would know exactly where that curve is. So let me give you an example here. F prime is x to the negative 3rd. All right. So if I do the integral of f prime, that's the integral of x to the negative 3. I'm going to get x to the negative 2 over negative 2 plus c, right? This is f, right? If I do the antiderivative of a derivative, I should get my function. So I have negative 2 over x squared plus c. I know that f of 1 is 3/2. So what I'm going to do is I'm going to plug in 1 for x. And I'm going to say, hey, I know that's equal to 3/2. And I'm going to solve for c. All right, negative 2 plus c equals 3/2. So c is equal to, oops, I don't know why I put the 2 on the top there. I was tripping. I was straight tripping, as people would say. Man, come on. All right, negative 1/2. There we go. I knew there was a little error there somewhere. All right, so when we add 1/2 there, we're going to get 4/2, which is, so we're going to add 1/2 to both sides, and we're going to get 4/2, which is 2. All right, so that's my my solve for c there. So now I know what f of x is. So I can say f of x is equal to negative 1 over 2x squared plus 2. All right, and then that would be my function. So I'd want to solve for c if I'm given an initial condition. All right, let's do one more, and then we'll be done. All right, so as I mentioned before, if I have the derivative of if I do the antiderivative of a derivative, I should end up with my function, right? If I have the derivative of an antiderivative, I should really just end up with what I have inside. So this is 5 root x minus 1 over x squared. Done. All right, I don't really have to do any more. So if I take a derivative and antiderivative, I just get what's inside. All right. Okay, so that's it for this video, guys. When we come back, I'll talk about, when I get my next video, I'll talk about acceleration and position, velocity, acceleration. Okay, so that's coming up next. We will see you soon. Have a good morning if this is morning. Bye.